Next, 2 square or 2 by 2 factorial design. So factorial design experiment involves simultaneously more than 2 factors. That means more than 2 independent variables, right? And each factor is at 2 or more levels. That means if you are taking water, low temperature, high temperature, you can split levels, that is level. So yield is dependent on water, right? Yield is dependent variable, water is independent variable. For example, I am telling you, right? So you can split water into 3 category: cold, warm, hot, like that. Weather can be splitted into various levels, various seasons, right? Winter, summer, right? Like that. Monsoon, right? That is the level. To assess their effects on a dependent variable. So a 2 square or 2 by 2 factorial design is a type of experimental design that allows to understand the effects of 2 independent variables, each with 2 levels, on a single dependent variable. So independent variable 1 and 2, right? So level 1, level 2, dependent variable. Based on that treatment, what yield you are getting. So dependent variable, right? Suppose we want to understand the effect of 2 independent variables. One is sunlight, level low level, next sunlight high level. Then watering, factor 2, daily or weekly, right? 2 levels. And the growth of certain species of plant, dependent variable, right? So this will be like this: daily, weekly watering, one independent variable, other independent variable sunlight, right? Low, high, 2 levels, right? So plant growth, or you can take the yield also, right? How you are getting the yield when the sunlight is low and watering daily. Sunlight is low, watering weekly, right? Sunlight is high, watering daily. Sunlight is high and watering weekly, right? The purpose of 2 square factorial design, right? 2 square factorial design allows you to analyze the following 2 effects: main effects and interaction effect. Main effects means the effects is just one independent variable as on the dependent variable are called main effects, right? Example, in above example we could analyze the following main effects. Main effects of sunlight on plant growth, right? We can find the mean plant growth of all plants that received low sunlight. We can find the mean plant growth of plant that receives the high sunlight. Main effects of watering frequency on plant growth. We can find mean plant growth of all plants that were watered daily. So similarly, the plant growth depend upon the watered weekly. So interaction effect. These are all the main effects. So low effect, so yield. Low sunlight, yield. High sunlight, yield. Weekly watering, yield. Daily watering, yield. That are main interaction effect. The effect that one independent variable has on the dependent variable depends on the level of other independent variable. That is, in the above example, following interaction. Does the effect of sunlight on plant growth depend on watering frequency? So yield is depend on watering frequency or not. So interaction, right? Otherwise, you can watering frequency on plant growth depend on the amount of sunlight. So watering, so daily whatever it is, weekly, sunlight is, if it is low then high, what is the effect, what is the yield? So this is interaction between two independent variable, right? Watering on One independent variable is sunlight, another independent variable is watering. So we are the interaction between two independent variables. Next we are going to see some notations. Capital A and B are two factors. The treatment combination, right, or A, B, A, B within bracket 1, right? These are all the combinations, right? So first A, B, low, low, that is 1 within bracket, small a, high, low, B is low, high, and A into B, high, high. So we can use plus for high level, minus for low level. We can use 1 for high level and 0 for low level. That is also there. These are all the notations, right? So treatment combination 1. So low, low means minus. We can use negative sign, right? Instead of low, low, writing instead of low, low, high, low, right? For high, plus. Or you can use 0, 0, 1, 0, 0, 1. These are all the notations. Analysis of variance for 2 square factorial design. Procedure, first n. Capital N is the number of data. So number of item in the data. N is number of treatments, replication block. First step, defining hypothesis. Null hypothesis, there is no difference in the mean effect. Alternate hypothesis, there is difference in mean effect. Step 2, prepare table 1 calculation for ANOVA. So first write this. So within bracket A, small a, B, A, B, right? So number of blocks, right? Then calculate as per this row total, summation, sum of squares, correction factor. Step 3, find A contrast. That means, so within the square bracket A, that is the notation. The formula is AB minus B plus A minus 1 in brackets. Next to B contrast, that is within square bracket B, that is equal to AB plus B minus A minus 1 in bracket. So these are all the notations. We are the values are taken from the table, above table. Then AB contrast, yes, so square bracket AB minus A minus B plus 1. Step 4, find the total sum of square, right? So same formula, and find the contrast A sum of square, ASS. So formula is A contrast square by 4n. Next contrast B sum of square, BSS, B contrast square by 4n. Then contrast AB sum of square, ABSS, AB contrast square by 4n. Next find error sum of square, ESS, TSS minus ASS plus BSS plus ABSS. Find the mean sum of squares, contrast A, MASS. Contrast A sum of square, right, ASS by degrees of freedom, V1, that is equal to 1 only, right? That is ASS, right? And similarly, mean sum of square by for contrast B, MBSS, that is also BSS. Next, mean sum of square by for contrast AB, that is contrast AB only, ABSS. Then error sum of square, mean sum of square for errors. Next, prepare ANOVA table, source of variation, AB error. You can use small a, B, AB also. So I am taking capital, right? Capital letters here. Sum of squares, ESS, BSS, ABSS, ESS, then total sum of squares. Then degrees of freedom for error 4 into n minus 1. Remaining all 1, right? Then mean sum of square, right? Then find with respect to A ratio F, with respect to B ratio F, and with respect to AB ratio F. So it's same like previous calculation, that is one-way classification, two-way classification, three-way classification. Like that you have to calculate f. So highest value in the numerator, lowest value in the denominator. Then you have to calculate the tabulated value and then you have to compare. Then conclusion, calculated value greater than tabulated value, as usual you reject hypothesis, null hypothesis for A, B, A, B and A, B. Similarly, if it is less than, then you accept the null hypothesis, right, for A, B and A, B. So first conclusion based on the method one way, two way, Latin square we are using to solve factorial design, right. Main effect of A is equal to contrast A by 2n. Main effect of B is equal to contrast B by 2n. Main effect of interaction AB is equal to contrast AB by 2n. So main effect of AB, right, both are same. Advantage and disadvantage. So advantages, factorial design are more efficient and factorial designs are allow additional factors to examine at no additional cost, right, that is the important one. It enables us to study the effect of each and every factor to be estimated and tested independently, that is also there by usual analysis of variance. Next, disadvantages. The main disadvantage is the difficulty of experimenting with more than two factors, because this is 2 by 2 or many levels. If the number of factors is more, then the number of experimental become very large, right. Factors are more, then it will be very big one. So in 2 by 5 factorial addition, 32 treatments combination, so big table, see. So 2 by 2 is the smallest, that is the easiest. So more than 2 by 2, then it will be very difficult. That is 2 square means 2 by 2. 2 cube, 2 power 4, 2 power 5 are very difficult. Means it is very large, what is that, you have to prepare very big table, then calculation is very tedious, that is what. Thanks.